Hi, I'm Jim Cattrall from Maertron, and today we're going to be talking about a NMEA 2000 network, and we're going to talk about how to build a NMEA 2000 network. So when thinking about building a NMEA 2000 network, you've got to understand the topology of a NMEA 2000 network. The first part is a terminology that we call a backbone. So a backbone is, you can think of it as like a highway of data that is flowing from one device through to another. Okay, and a backbone starts at one end and goes right through to the other end, and this is our backbone. Okay, so a backbone, you could think of it from going from bow to stern, or you could think of it going from stern all the way up to the top of the mast, and it snakes through the boat, passing all of the different devices that you're trying to connect to your network. When you're feeding it through the boat, you want to think about trying to get as close to the devices that you're trying to connect as possible. As then we have drop cables, okay? And a drop cable is where we introduce these different devices, and we do that by inserting a T-piece, okay? So a T-piece then allows us to connect a drop cable from the backbone through to the device. That drop cable can be a maximum length of 6 meters. Okay, so when you're trying to get the backbone through the boat, that's why you want to try and get it as close to the devices as possible. So when creating a backbone, you have several different pieces to it. You've got a power injector, you've got T-pieces to add all of your different devices, you've got the terminators, one for each end, you've got a display to show your information on, and then you've got different devices with different types of data that you want to show on your display. Then you have the different types of cables, and in this instance we are using a micro cable. These come pre-made. They can either come from 0.5 meter all the way up to 10 meters, or you can actually make your own cables using our bulk cables. If you're using the bulk cable, or if you need to cut a pre-made cable, you can always cut it. You can always use a field installable connector to make up those cables. Okay, so now we've done that. So the first thing that we need to do is create our backbone. So we have a power T, we inject 12 volts. So the power range of a micro network is, or NMEA 2000 network, is 12 volts. It can go anywhere from 9 volts all the way up to 15 volts. We would recommend using a power injector, so something like a DC-DC converter, where you can control the voltage going into your network. And ideally, you would want a stable voltage somewhere around about 13.8, 14 volts. That will allow for the length of your network and allow for voltage drop over the network, and try and keep the ends of the voltage above 9 volts is what you're trying to do. So, in making an NMEA 2000 network, we've got the power T, we've added our power, now we want to add the T's. Okay, so in order to do this, we connect the T's in, we push them in, we tighten them up, we make sure that they are tight so that they don't vibrate loose while you're sailing along. Then we add to the other side of the network, and we try and balance out the network so we've got the same amount of load or devices on one side as we do on the other. We have spoken previously in a different video about len value and trying to balance out your network. In this case, we have 2 devices here, one with a value of 1 len, one with a value of 2 len. Then we have a display that's got a len value of 9 len. So it's not really going to balance out, but what we're going to try and do is do the best that we can, which is to add the display to one side of our network. Okay, and that's in nice and tight. Then we're going to add our GPS antenna. Again, nice and tight. Then we're going to add our wind sensor. So when you are connecting cables to a device, you will notice that all devices have a male connector on them. So when you are either making up your cables or trying to insert your cables, you want to make sure that you've got the female end run through to your device. You don't want to run the cable through your mast and find out you've got it the wrong way around. So again, we're going to connect the wind sensor into our network. These connectors can only go in one way. There is actually a little tab inside the connector, a little locator tab, that will only allow it to go in one way. So you need to make sure you've got it the right way around. Then we make sure that we've got our terminators, and in this case we're using 2 male terminators. And the reason for that is that our power T has 2 female connectors on it. And because we've not changed the gender of any of this network, we end up with 2 female connectors either side, so we need 2 male terminators. So the reason for the terminators is to reflect the data. So right now the data is coming back and forth down the backbone, and it goes off to each device so that you can then see the information on the display. The idea of the terminators is to reflect that data, so once it gets to the end, it then sends it back down the network. If you don't have them, you can get corrupted backbone data and network. You will also notice in this network I have a T that I'm not connecting at the moment, and it's always a good idea on an NMEA 2000 network to have a spare T, because you may need to connect either a new device that you want to try and connect and you don't want to disturb your backbone, or you need to connect a gateway to try and configure any of the devices that you've got on the network. But at the moment we're not going to be using it, so we actually have caps, and these come in both male and female, and this one is a male to go into the bottom of the T, and we're going to insert that in there so that we don't get any debris in there or salt water into there or anything like that, so that when you're out sailing you've got a place to be able to connect your gateway in, to be able to troubleshoot your network or configure any of the devices, but you've also secured it. Okay, so we've shown it to you in this configuration. However, maybe in real life your wind transducer will be up at the top of the mast, and therefore 6 meters of cable won't be enough. So what do you do now? So that's where our inline terminator comes into play. So with this situation now, you would disconnect what is now your drop cable from the network. You would disconnect it from the wind sensor. You would insert your inline terminator to the wind sensor, and again making sure that it's tight. Now you would insert your cable now this cable is going to represent your backbone. Okay, so in this instance now we have a terminator here at the wind transducer. We also have a terminator at either end of our network. So on any NMEA 2000 network you only want 2 terminators. Okay, so what we're now going to do is, rather than connecting it to the bottom of the drop T, what we're going to do is remove our terminator from the end of the network. I'm going to set that to one side. Now we're going to add our backbone cable, which is going all the way up our mast. Imaginary. All the way up our mast, and now we have our backbone that goes all the way from this terminator, comes up our imaginary mast, all the way to our wind sensor, where we have a terminator at the far end of there. And that's how we build an NMEA 2000 network. I hope you've enjoyed the video. Thanks very much for watching. Please like and subscribe for more videos.